Good morning and happy Saturday from Mahia, New Zealand, where our Electron rocket is ready on the pad at RocketLab's Launch Complex 1 as we count down to its 11:01 a.m. local time liftoff for today's mission. On board Electron today is our return customer Kinéis as we prepare to launch the second of multiple launches for them to deploy their Internet of Things constellation to space. My name is Prachi Saknani, and with me is Andrew Haig, and together we are live from Mission Control Center in Auckland, New Zealand for our 53rd Electron launch.
Well, thanks, Prachi. It's great to be back on the pad with Electron again so quickly after we stood down from our launch attempt earlier this week. Now, a ground system sensor triggered Electron's flight computer to safely halt the mission right on T0 for that last attempt. But with Electron, the launch pad, and Kinéis' payload all healthy and ready for another launch attempt, we're back on the pad and ready to try again today, with greens across the board so far for our pre-launch operations.
Just 3 months after we launched them for the first time from Launch Complex 1.
Con un lanzamiento de la
That
empresa
mission
RocketLab.
launched our 50th
Electron
Electron
lanzó un
rocket
segundo
with the
conjunto de
first 5
satélites para la
satellites
startup
of their new
francesa Kinéis
IoT
el 20 de
constellation
septiembre,
successfully
poniendo a la
deployed
compañía en
to
camino
their
a
new
comenzar a
home
ofrecer
at
servicios de Internet.
635 kilometers above
El
Earth,
Electron
just
despegó del
66
complejo de
minutes after
lanzamiento 1 de
liftoff.
RocketLab en Nueva
Now, we'll be
Zelanda a las
launching
7:01
5
del este de
missions
Estados
overall, with 5
Unidos.
satellites on board
Los 5
each time.
satélites a bordo se
And each
desplegaron
launch
en
is
órbitas
tailored
heliosincrónicas a
specifically
una
to
altitud de
Kinéis' mission
643
requirements.
kilómetros, poco
That
más de
includes
una hora
instantaneous
después.
launch windows like for
Este
today's
lanzamiento
mission,
es el
but
segundo de
also
5
a
que Kinéis
precise
adquirió de
payload
RocketLab en
deployment,
2021,
first with a single
después de uno en
satellite
junio.
and then in pairs
Los
to
5
build out the
lanzamientos desplegarán una constelación de
exactly as
25
Kinéis
satélites
needs
que
it.
Kinéis utilizará
Let's hear
para
more
brindar
from the team
servicios de
at
IoT a nivel
Kinéis.
mundial.
Kinéis is a French company based in Toulouse. We are a satellite operator and a global connectivity provider dedicated to the Internet of Things. Mountains, ocean, deserts. 85% of our planet has no network coverage. In 2020, we raised a large amount of 100 million euros to address this global issue. Today, we are following through and will deploy a constellation of 25 nanosatellites that will enable us to connect to a multitude of objects anywhere on the planet in near real time. We are convinced that this transmission of information made possible by satellite connectivity will enable us to respond to crucial challenges for mankind, its activities and its environments.
Antes de continuar con el lanzamiento, veamos algunas novedades del mundo espacial. ¿Se acuerdan de los 2 astronautas de la Starliner? Suni Williams y Buzz Wilmore, los 2 astronautas que viajaron a la Estación Espacial Internacional el pasado junio, por problemas técnicos con el Boeing Starliner, no volverán hasta febrero de 2025, tienen asegurado su derecho al voto en las elecciones presidenciales de Estados Unidos del próximo 5 de noviembre. Así lo confirmaron esta semana en una conferencia para después, en un vídeo publicado por la NASA, animar a la participación en los comicios que consideraron un deber importante que tenemos todos los ciudadanos. Ambos han solicitado el denominado voto por correo espacial, un derecho de los astronautas estadounidenses que fue autorizado por una ley promulgada en el estado de Texas en 1997, que ya se ha ejercido en varias ocasiones. Les dejo un fragmento de lo anunciado.
Have you requested your absentee ballots yet so you can vote from space? If you could elaborate on this, and what else are you missing on a personal note?
I sent down my request for a ballot today, as a matter of fact, and they should get it to us in a couple of weeks. And absolutely, yes, it's a very important role that we all play as citizens, is to be included in those elections, and NASA makes it very easy for us to do that. So we're excited about that opportunity.
And Marcia, same here. You know, it's a very important duty that we have as citizens, and looking forward to being able to vote from space, which is pretty cool. You asked what we miss, right? Of course, you know, the things that we always miss, our families. I miss my 2 dogs. I miss my friends. But you know what? Like Butch said, there's so many people on Earth that are sending us messages, and it makes you feel just right at home with everybody when we're able to have those conversations with our friends and family at home. So I know they understand. I know it's tough on them as well as, you know, being away from home, of course. But everybody understands, and everybody's cheering for us to get back with Crew 9.
Now, today's Electron rocket is our standard platform orbital launch vehicle capable of lifting up to 320 kilograms of payload to space. Electron stands at 18 meters or 59 feet tall and is primarily made with a carbon composite material, which is why our rocket looks black when it's not fueled. Now, Electron is the world's first carbon composite orbital rocket powered by the world's first 3D printed battery-powered rocket engines to make it to space. 9 of these Rutherford engines are located at the bottom of the rocket's first stage, and a single Rutherford engine with an expanded nozzle is used on the second stage. Now, all of the Rutherford engines across the rocket use batteries to power their turbopumps, and Electron performs a unique launch maneuver called a battery hot swap that happens part way through the mission to replace the second stage engine's used up batteries for new ones. Now, across the first and second stage, the engines use a propellant mix of kerosene and liquid oxygen, and it's that second propellant's super cold temperatures that make the outside of Electron look white, because that's where condensation has turned to ice. Now, without the propellants, Electron weighs in at just over 1,000 kilograms, but when the rocket is fully fueled, Electron weighs 13,000 kilograms.
At the top of the rocket within its fairing is where you'll find today's payloads of 5 satellites for Kinéis. As you can see, they're attached to the kick stage platform, from which they'll be deployed once they reach their destination. So, for today's mission, we are headed on a 643-kilometer orbit on a southern trajectory from Launch Complex 1. 2 seconds before T0, Electron's 9 Rutherford engines will ignite for liftoff, and the pad's hold-down mechanisms will be released, allowing Electron to travel upward for a short while before curving its path to continue its climb, but more horizontally. The rocket speed will continue to increase until it reaches max Q, or maximum aerodynamic pressure, just under 2 minutes from liftoff. 2 minutes from liftoff. Once it clears that first milestone, the next step in Electron's journey will be MECO. This main engine cutoff is when the first stage from the rocket shuts down and separates from the second, before the single Rutherford engine on stage 2 lights up to continue the mission to orbit. We'll have a repeat of that separation for stage 2 and the kick stage about 7 minutes later, and the kick stage will finish the mission by delivering Kinéis satellites to orbit. Once that's done, we'll also have the kick stage perform a perigee-lowering burn that will help reduce these stages' orbital lifetime as part of our effort to keep space sustainable.
All right, so there's just 4 minutes 20 seconds remaining in the count to liftoff for Kinéis, killed the RadIOT star. At T-minus 2 minutes, Electron's flight computer will take over the countdown and autonomously run through its final operations. A liquid oxygen will continue to flow into Electron all the way up to T-minus 1 minute and 30 seconds.
That's right, and after that, we'll hear confirmation that Electron's first and second stages are fully pressurized and ready for launch. And then it's over to our launch director, Michael Pearson, for the iconic 10-second countdown. For now, let's send it to Mission Control so they can send it to space, and we'll check back in with you after liftoff.
LOX load is complete. System is in recirculation. Anti-geyser is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. Stage 1 propulsion nominal.
T plus 35 seconds and counting, and we are well on our way to space. Our 53rd Electron rocket has taken flight, and it's headed to orbit with its payloads for Kinéis. Up next, you'll hear the call for max Q, or maximum aerodynamic pressure, the point in flight where Electron experiences peak structural load. The GNC operator on console will give us the call that max Q is approaching, and then we'll hear for confirmation that we have passed through that gate.
HV discharges nominal.
Cleared max Q. MECO confirmed.
State separation confirmed.
We might see this happen on screen, so let's keep an eye out for that.
Fairing jettison succeeded.
And that was a call out for fairing jettison from mission control, exposing the payload to space ahead of deployment. Electron is traveling at over 8,500 kilometers an hour at an altitude of 125 kilometers, with just a few minutes remaining in the second stage burn. Swap on the second stage confirmed as successful by mission control across the nets. Up next is the final stage of stage 2 flight, including cinco, or second engine cutoff, followed by kick stage separation. This is where the kick stage, carrying the 5 Kinéis satellites, separates from Electron's second stage. That final engine cutoff is coming up just shy of 9 minutes, so only about 3.5 minutes to go.
Stage 2 propulsion holding nominal.
Welcome back to the launch of Kinéis Kills the RadIOT Star, our 53rd Electron launch. Just over an hour ago, Electron lifted off from Pad A at Launch Complex 1 in New Zealand, carrying 5 satellites for French IoT company Kinéis. The satellites are now just minutes away from being deployed to their final positions in space. The kick stage's Curie engine is performing 2 burns today, and while we were on our break, we've already had our first ignition and cutoff. This Curie burn lasted about 2.5 minutes to round out our orbit from its 643-kilometer apogee. We've mentioned Curie a few times this launch, and we've talked about our small but mighty engine prior to liftoff. But just how small is it? Well, check it out here.
Now, named after physicist Marie Curie, this extremely small engine is capable of some very big maneuvers. We've flown this engine on all but our first mission, and it allows us to raise and lower our orbits, perform plane changes on orbit, and it's responsible for our pinpoint payload deployment accuracy. Now, this version we have here is the Curie Mark III, and it's not just used on Electron's kick stage. This engine is used on a lot of our spacecraft missions as well. The Mark III engine used here is in the satellites that we're building for Varda's in-space pharmaceutical manufacturing, and we flew a variant of this engine to the moon back in 2022 as part of the capstone mission for NASA.
With only a few more milestones left in this mission, the second Curie burn comes next, lasting just 8 seconds. This is a slight orbit adjustment specific to our customer's mission before the deployment sequence begins. The satellites will deploy approximately 45 seconds apart, starting with the forwardmost satellite.
Curie ignition confirmed. Curie engine cutoff confirmed.
Great news there to have Curie engine shutdown confirmed by mission control for the kick stage. Now up next is our last mission milestone, the payload deployment for the next 5 satellites for Kinéis' constellation. Each Kinéis satellite is a 16U platform weighing about 30 kilograms or 66 pounds. As we've mentioned already, the 5 satellites currently attached to the kick stage will be deployed in a particular order. We'll first deploy the top spacecraft as the first event, and then we deploy the next 2 satellites that are attached opposite to one another on the payload structure. And finally, we'll do the same thing again with the last 2 spacecraft.
Alexandre Tisserand, presidente y director ejecutivo de Kinéis, dijo en un evento celebrado el 17 de septiembre en el marco de la Semana Mundial de Negocios Espaciales que la compañía esperaba lanzar los 15 satélites restantes para el primer trimestre de 2025. La compañía ofrecerá un servicio inicial utilizando los 10 satélites que ahora están en órbita en enero. La constelación completa, que entrará en servicio a mediados de 2025, permitirá a los clientes recopilar datos de seguimiento de activos y otros datos con una latencia de entre 15 y 20 minutos, lo que supone un tiempo muy bueno para el 90 o 95% de los casos de uso, afirmó. Eso pondría a la empresa en camino de lograr la rentabilidad en 3 años. Tisserand dijo que Kinéis planea destacarse entre las empresas que también ofrecen servicios de IoT a través de dispositivos más pequeños, menos costosos y que consumen menos energía. La competencia es demasiado cara o no lo suficientemente pequeña. Eso es lo que vemos hoy en el mercado, dijo. El lanzamiento de los satélites es un factor diferenciador, afirmó. Hay tantos anuncios, tantos proyectos que prometen algo. Cuando hay alguien que realmente realiza el lanzamiento, que ofrece un servicio real, realmente se nota la diferencia. Este lanzamiento fue el 11º de este año realizado por RocketLab, un récord para la empresa. La empresa ha argumentado que los clientes como Kinéis que tienen requisitos orbitales específicos para su constelación, validan la necesidad de vehículos de lanzamiento pequeños y dedicados como Electron a pesar de la fuerte competencia en precio de los servicios de viajes compartidos transporter de SpaceX. Vemos a muchos clientes que se embarcan en una misión de transporte compartido y llevan prototipos y otras cosas a la órbita, dijo Peter Beck, director ejecutivo de RocketLab, en el evento. Cuando esas empresas necesitan desplegar naves espaciales operativas en órbitas precisas, entonces las vemos salir de transporter y colocarlas en una plataforma dedicada. Creemos que los viajes compartidos son geniales para la industria. Es una gran oportunidad, especialmente para las empresas en sus primeras etapas, de poner algo en órbita y obtener un punto de prueba, agregó. Pero siempre existe la necesidad de un lanzamiento pequeño y dedicado. Si llegaste hasta acá te pido un like, compartí con un amigo y suscríbete para estar informado. Hasta acá llegó este lanzamiento, te mando un abrazo y nos vemos en el próximo lanzamiento.